Good morning, friends. My name is Riaan Nolan, and I'm a HashiCorp ambassador. I'm also a Terraform trainer. And when I present these labs, typically I require people to have Terraform installed, but they are not always admins on their local computers. So I'd like to share with you this lab I've got called HashiCube, which allows you to run all of the Terraform products and integrate this with popular open source tools such as GitLab, Minikube for Kubernetes, and AWS Ansible Tower, MySQL, and so on and so forth. So with that, let me quickly share my screen with you. Share. So as you can see here, I'm at HashiCube's GitHub repository. Now, this will be familiar to most of you. What you are going to do is you are going to fork this repository, which means it will create a copy in your own GitHub account. Now, when you click this code button, you would be familiar with this cloning section over here, but you will also see Codespaces. Now, you can then create new Codespace. Now, what this will do is it will open up a new window and it will launch HashiCube on the internet for you in a VS Code dev container, which is what you see here. This is kind of VS Code. Now, it's very easy. For us to create a vault, we would simply do bash vault vault.sh. Now, what this is going to do is on the left-hand side, you see a bunch of folders. And one of these folders is Vault. So if we expand Vault, you will see there's a vault.sh. Now, vault.sh simply installs Vault for us, sets a config file, and initializes it and unseal Vault so that we can start using this Vault. But here is where the secret sauce comes in. This Vault will be available on the internet. So that only took a minute or so. If you click here on ports, you will see 8200, and that is what Vault is. Now, if we click on this little button over here, you will see that the Vault interface will open up for us. And indeed it does. So this Vault is live on the internet. So let's take our root token. You can see here the initial root token. Let's copy that and let's paste this in here and let's log in. Well, here you have your own Vault live on the internet that you can test your secrets engines with, and you can test your Vault policies, and you can test your access. But that's not all. HashiCube runs all of the HashiCorp products. So I'm a Terraform trainer, and I teach a lot of students how to write Terraform and accelerate their maturity in their infrastructure as code journey. So let's try and bring up Terraform. So what we will do is we will use bash again, and we will go into local stack and local stack.sh, and we're going to execute that. Now, local stack is a local Docker container that mocks the AWS APIs. So you can create an S3 bucket, you can create an RDS, you can create Lambda code, and you can test your Terraform code before you deploy this. And you can actually practice with this for free on your local system. Now, what is going to happen is when we do bash local stack, it's going to go into local stack and it's going to run this local stack.sh. Again, it's going to bring up our Docker for us, make sure that we've got AWS CLI installed. It's going to install AWS local, which is a pip utility. Now, for those of you familiar with AWS, usually you would do AWS S3LS to list your S3 buckets. Using local stack, you can do AWS local S3LS. And what's going to happen is it will use the provider defined in the provider.tf over here. And you will see that these endpoints, we are actually rewriting them to localhost port 4566, right? And so S3 is no different. Here is our S3 URL. So when we write a little bit of Terraform code, which is over here, and we tell it that we want to create an S3 bucket. If we just quickly find where that is defined, here. If we say we want an S3 bucket titled my bucket, Terraform is going to create this for us. Now here it's busy installing our AWS local utility. It's now pulling down our local stack container for us. And once this is live, it's going to do a Terraform init for us based on this code. It's going to do a Terraform FNT, Terraform format, to make sure our code is nicely formatted. And then it is going to do a Terraform validate to make sure that our code is going to run. So here it's busy doing a Terraform init. Now it is going to do Terraform validate for us. And now it's going to do Terraform plan for us, and then Terraform apply. So here is our plan output. It's telling us that it's going to create an S3 bucket for us, all right? It's titled my bucket, and it's subsequently going to create it for us. It's going to apply and create this bucket for us. Now, this is our Terraform output. So if we do AWS local S3 ls, we will see that we have my bucket, S3 bucket installed. Now, how this works, if you go to local stack.cloud, right, and I've already registered, and if you sign in, I've already signed in here, and here is my local stack instance. It says it's offline, but it's not really offline, which is weird. But if I click here on S3, then it should show me my S3 browser. Nevertheless, here is my code. If I make any changes to it, let's say I call this let's say I add a new bucket over here, and I just go Control-C, Control-V, and I call this my new bucket. And call this my new bucket, and we save, and we go Terraform plan inside our local stack directory. Terraform plan. Then we will see that it wants to create a new bucket for us. So here is our new bucket that it wants to create for us. And if we then go Terraform apply, it's going to create our new bucket. Now, friends, that is quick and easy. In a follow-up video, I will go in depth into what a dev container is. How do we get a dev container up and running? How can you use this in your own projects? Let's hit yes over here. Thank you very much for joining me, and I hope you have a fantastic day.